All right, hello everybody. This is CCNP Seth here, and today I'm going to be talking about frame relay, not so much on the customer side, but from a service provider's perspective. When I was studying for CCNA and was learning about frame relay, all we had to do was configure frame relay and understand frame relay from the customer side. And when you would want to practice this, whether in GNS3 or in Packet Tracer or something like that, you would just input this frame relay emulator switch type thing. And I wanted to know how to actually service providers do it, or possibly what is a way a service provider can make this frame relay connection. And I've seen videos where you could have this cloud looking thing like this, and normally it would just be one router, and DELCs would go in one interface and then out the other interface. That really didn't sit well with me. Like, I want to know, how does this DELC number get all the way across the service provider network to the other edge router to the distant end of a frame relay connection? So I did some research, tried to figure it out, and this is the commands that I'm going to be putting on R4. Everything else is configured, and you're just waiting for this to be put in, and then we'll have frame relay connections. Also, the thing about frame relay in a service provider's perspective is that only these edge routers need to be set up for frame relay. This cloud right here, which is actually a router right here, but it's connecting these edge routers right here, he has no idea about frame relay. He's not even set up for it. So what I'm going to do is going to build a GRE tunnel from one provider edge to the other provider, to the other side of the provider, and do these configs right here. And this is how I believe service providers can configure this. So let's configure R4. So here we go, the R4. And first, let's build the GRE tunnel. So go into global config mode, interface tunnel, and then give it a number, 46. I just did that because it is for router 4 and router 6 right here. Same thing with tunnel 47, 4 and 7. So let me bring that back up. So let's see here, interface tunnel 46, and we got to give it an IP address, but in this instance, I am not going to be using one, but I will reference an interface just so it can get IP traffic going. Then do a tunnel source of a loopback 1, and then the tunnel destination for router 6 would be its loopback, which is 6.6.6.6. Hit that, and let's bring up the other one. Interface tunnel 47, and I can give it a description if I want, but do IP unnumbered serial 01 tunnel source loopback 1 tunnel destination 7.7.7.7. and as you noticed, you could have seen these messages come up. The tunnel was already built on the other side, so the line protocols are coming up. Also, the OSPF adjacencies are coming up for my service provider cloud right here. So everything is good to go for that. So now let's actually, let's do a show IP interface brief right here. Squished it too much. Let's do that again. And here you can see my tunnels. They are up and up. This IP address is just referencing that serial 01. That's okay. So let's configure the actual frame relay portion of it. So let's go into interface serial 0/0, and we will do no IP address because we don't need one there. Do encapsulation frame relay because again it's a serial connection. And to get this going, you have to do this frame relay interface type DCE. So if you don't do that, this will not work from the service provider's perspective. DCE. Now this is where we actually connect DELCs together. So it says frame relay route. If I have a DELC of 102, I'm going to send it out an interface, and I'm going to send it out interface tunnel, depending on where it's going. So 102 is going to tunnel 47, and then my output DELC, I only have to use one extra DELC between the service provider edge routers, so that will be 47. Then if I do the up arrow and do another connection, frame relay 103, and it's going to take tunnel 46, and the DELC is going to be 46. That should be it. Let me minimize this and show you what's going on here. So this headquarters router has a mapping of 103 all the way to 301 for its branch router over here for branch 2. Same thing with 102. It has a DELC connection to 201. So the way Frame Relay works is, all right, incoming DELC comes in this interface, outgoing DELC, it has to be another number and it has to go out an interface. So if we're trying to span this across our service provider cloud, then we'd have to have a DELC here, and then however many routers there are, another DELC, another DELC, another DELC, so on and so forth, where you could actually just create almost like a direct connection, but it's logical, which is a GRE tunnel. So that's like pretty much all I had to do, and that's it. I created a GRE tunnel here and a GRE tunnel from 4 to 6, and told these incoming DELCs to go out the tunnel interface, so it'll use this DELC right here. And then once I went to router 6, I did the same mapping. Incoming DELC of 301, outgoing DELC is 46 through the tunnel, and that's just how it works. If I go to, let's clear all that. If I go to R4 and do a show frame, map frame route. There you go. You can see what the input DELC is and the output DELC. So that is how it actually works. Hope this gives you a little bit better understanding of Frame Relay from the service provider's perspective. Everything else on the branch routers are still the same. If I go to headquarters and if I do a show frame relay map, everything's still there, so show IP route. Oh, we have one OSPF connection, but should still yeah. So if you have any questions, leave a comment below. But I hope this was informative for you, and I'd like to thank you for viewing.